Section 3.2 Quadratic Functions. Let's begin with the parabola. The graph of a quadratic function is a U-shaped curve called a parabola. One important feature of the graph is that it has an extreme point called the vertex. And when we're talking about the vertex, the special point is also always referred as h comma k, where h is your x coordinate and k is your y coordinate. So here we have some important features of a parabola. Of course, just like a line, we have intercepts, so points that cross your y-axis would be your y-intercept, and points that cross your x-axis would be your x-intercepts. And then the important feature we just talked about was the vertex, which is that extreme point. If it opens up, it's your lowest most point, it's your minimum. And if you are opening it, if it opens down, it's that max point right there. And another important feature of the parabola is the axis of symmetry, which is, well, actually, this parabola is a mirror image of itself. We cut it right down the half. So this axis of symmetry cuts our parabola right down the center. Understanding how the graphs of the parabolas are related to their quadratic functions. The general form of the quadratic function is f of x equals ax squared plus bx plus c. The standard form of the quadratic function presents the function of the form f of x equals ax minus h squared plus k, where hk is our vertex. And we have that same thing written below. What's nice about the standard form is that I can easily pick out your vertex, your h comma k. When it's written in general form, I can't pick it out as easily. For that, I have to use this formula. To find our h of our slope, To find the h of our vertex, we use the values negative b over 2a. To find the k, we just input those values into our function, f of negative b over 2a. Example, find the vertex of the quadratic function. Rewrite the quadratic in standard form. Why don't we go ahead and just write it in standard form, since that will let us pick out the vertex. All right. So in standard form, we want to have a times x minus h squared plus k. In order to have that, I need to create something squared. So to get there, I would have to complete the square. So I suggest you first move your constant. So minus 7, we have f of x minus 7 is equal to 2. And then factor your leading coefficient. 2x squared, and then negative 6 divided by 2, negative 3x. All right, I left some space there because now we're going to complete the square. You're going to take your value, b, and divide it by 2 and square it. This is your formula, b over 2 squared. All right, my b is at 3. So you have negative 3 divided by 2 squared. And we don't have to fully square. We can just go ahead and leave it like that. So that would be 9 over 4. All right, so what we have caused and created now is a perfect square trinomial. So this trinomial will factor to be the same thing twice. Now, a hint, especially when you have fractions, it's always a number you have before you square. So this factors to be 2 times x minus 3 over 2 squared. We added that 9 over 4, but when you add to one side of the equation, you have to add to the other side as well. Now, because it's within parentheses, I have to multiply it to the number on the outside. So 9 over 4 times 2, well, that just gives me 9 over 2. So on the other side of my equation, I have negative 7 plus 9 over 2. Well, that gives us negative, we need a common denominator, negative 14 over 2 plus 9 over 2. We get negative 5 over 2. So we have f of x minus 5 over 2. We want f of x back by itself, so we add 5 over 2 to both sides. And we're left with f of x is equal to 2 times x minus 3 over 2 squared plus 5 over 2. Now we can easily pick out our vertex. So your vertex is always h comma k. But remember, those horizontal, well, because I have a minus in my standard equation, it causes a sign change. So our vertex would be positive 3 over 2 and positive 5 over 2. I know we see a negative in that 3 over 2, but that h is always opposite sign. Finding the domain and range of a quadratic function. Given a quadratic function, find the domain and range. Identify the domain of any quadratic function as all real numbers. So your domain is always all real numbers. Determine whether the a is positive or negative. If a is positive, the parabola has a minimum, meaning you lean coefficients positive, it's going to open up. So it's going to have a lowest peak, a minimum. If a is negative, the parabola has a maximum, meaning if it starts with a negative, it's going to open down, and therefore highest peak will be a maximum. Determine the maximum or minimum value of the parabola k. If the parabola has a minimum, the range is given by f of x is greater than k, or k to infinity. If the parabola has a maximum, the range is given by f of x less than or equal to k, or negative infinity to k. Remember that k comes from that vertex, h comma k. So let's say if it opens down, if it has a minimum, it opens up. So if it opens up, it's going to go to the highest peak, and my range would be that k and then up to infinity, hence this value. And if it opens down, if it has a maximum, some maximum peak, then the values can be just that k value from your vertex at hk and just keep going down to negative infinity forever on both sides. So that's how we go from negative infinity to k. So what's helpful about this is we have something that always works for our range. So find the domain and range. Well, domain we can do without a thought. The domain of a quadratic function is always all real numbers. So negative infinity to infinity. Your range just requires some effort. I need to find my vertex because I need to find the k of my vertex. To find the k of your vertex, let's use our formula. We have h is equal to negative b over 2a. All right. Now let's label our values. My a would be negative 5. My B would be 9, positive 9, and my C would be negative 1. So let's input them into our value for H. So we have H is equal to negative B, which is 9, divided by 2 times A, 2 times negative 5. So we're given negative 9 divided by negative 10. That is my H. To find my K, let's plug this into our function. So let's find f of negative 9 over negative 10. Or they're both negative. The negative divided by negative is positive, so I can just drop the negative. All right, so I have negative 5 times 9 over 10 squared plus 9 times 9 over 10 minus 1. All right, let's input those values. Let's simplify it. So that's negative 5 over 1. We can cross multiply. So 5 goes into 5 once, 10 goes in, 5 goes into 10 twice. Oh wait, I first have to square. Let's continue over here. So I have negative 5. I got ahead of myself. 9 times 9 is 81. 10 times 10 is 100. Plus 9 times 9 is 81 over 10 minus 1. There we go. Now we can cross multiply or cross cancel. So 5 goes into 5 once. 5 goes into 120 times. So we're left with negative 81 over 20 plus 81 over 10 minus 1. All right, then you get a common denominator. So this would be negative 81 over 20 times 2. 81 times 2 would give us 162. 162 over 20 minus 20 over 20. So we have negative 81 plus 162 minus 20. We have 62 over 20. And that can be simplified to 31 over 30. 31 over 10. And that is our K. Whew, all that work. So that we can say, well, let's think about it. We have a negative in our quadratic. There is a negative, so I know it's going to open down. It's going to open down. So I'm going to have a vertex that's considered a max value, a high value. So because of that, it's going to be my K and then all the way down to negative infinity. So my range is negative infinity to my K, which is 31 over 10. Determining the maximum and minimum of quadratic functions. All right. A backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as a 4th side. Find the formula of the area enclosed by the fence if the sides of the fencing perpendicular to the existing fence have a length of L. And B, what dimension should she make her garden to maximize the enclosed area? All right. So for A, I need to use formulas I know since I know we don't have that 3rd side. So this is our enclosed value we want to find. So we want to find the formula for the area of the fencing perpendicular to the existing fence having a length of L. All right, well, we know that all of it should add up to 80 feet. So if I add a length plus another length, since I have another length here, plus a width, that should give us 80, right? We have 2L, so we can combine like terms. I have 2L plus W is equal to 80. Now, we're going to try to figure this out, but what makes it kind of challenging is that we're missing this other side, right? In order to just use the formula straight off the bat. So let's create a formula. Let's create a formula from this. If I solve for W, that would give me W is equal to 80, and I subtract 2L to both sides, 2L. Now I can use this within our other formula that we know for area. Now area is made up of length times width, right? This was our perimeter, which was the sum of all sides. Okay, well, I know my length. I have all of my lengths needed to find the area. I have my 2 lengths. But my width, I only have 1. I don't have my 2 widths that I would use to find my area for length times width. I can use my new width that we found. So that we have A is equal to length times 80 minus 2L. And that would give us the formula. Once I distribute the L, so you multiply them in, of negative 2L squared plus 80L. That's cool. Does that look familiar? That's a quadratic. This will let us manipulate our lengths to find a maximum value for our fencing. All right. So what dimension should she make her garden to maximize the enclosed area? So notice our parabola has a negative. It's going to open downward. So that peak value is going to be a maximum of our dimensions for this problem. So let's go ahead and find the vertex. That vertex will help us find our maximum. So again, our formula is AL, why do I keep writing T, is equal to negative 2L squared plus 80L. We want to find our vertex. So the H is found by negative B over 2A. All right, my A is negative 2, and my B is 80, and I don't have a C. So my C is 0. Let's find that vertex. I have negative 80 divided by 2 times A. Oh, yeah. Negative 80 and 2 times A is 2 times negative 2. So we're left with negative 80 divided by 2 times negative 2, negative 4. And negative divided by negative is positive, so we have 80 divided by 4, which gives us 20. All right, that's our H. We need to find or plug it into our function to find our maximum value. So let's plug it in. So A of 20 would give us negative 20L squared plus 80L. So I have negative 20 times 20 squared. Oh, not 22. That's not 20. There we go. Plus 80 times 20. So we have negative 2 times 20 is 400 plus 80 times 20. We're left with 1600. All right. We're left with 2 times 400, that's 800. We have negative 800 plus 1600. That gives us 800. So this tells us that the maximum value of the function is the area of 800 feet, which occurs when our length is 20. So when you're working with these types of problems, we're trying to create a problem to find a maximum value or the lowest value of some type of story or function, right? And we're going to use formulas that we know depending on the shape we're given. Finding the x and y intercepts. How to? Given a quadratic function, f of x, the y and x intercepts. 1, you want to evaluate f of 0 and find the y-intercept. So you want to plug in 0. And then solve the quadratic equation to let f of x equal 0 and find the x-intercepts. So there, that one is the challenging part. So you're left to either solve for x, and if possible, you can factor, and hopefully that's the case because that would make it easier. If it's not factorable, you're left to do the quadratic formula. And that would give you your x-intercepts. Now, if you're left with x-intercepts with an I, then they're not points on our graph. That means our graph never touches the x-axis. And to remind you, your quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, let's take a look at this first example. Find the y and x intercepts of the quadratic. Well, y-intercept is my favorite because you just plug in 0. So f of 0 is 3 times 0 squared plus 5 times 0 minus 2. Well, anything times 0 is 0, so we're just left with negative 2. So my y-intercept is negative 2. Or if you want to, the point 0, negative 2. Your x-intercept requires a bit more effort. So let's see if this is factorable. Do we have numbers? So as we look at a polynomial as our quadratic, you have to rely on all your factoring techniques. And there's a review on this in your module, in your week 1 module. All right, so we have a of 3 and the c of negative 2. So I think I multiply them. Is there a number that I can multiply, give me negative 6, but add to give me my middle number? And that's 5. So if I have 6 times negative 1 gives me negative 6. But 6 plus negative 1, I get negative 5. All right, so maybe this can be factored by what's often called the AC method of factoring. Okay, so we have to expand to get 4 terms. We have 3x squared plus 6x minus 1x minus 2. And we got those numbers from our little thought process. So this factors to b. I can factor for my first two, I can factor out a 3x, so that I'm left with x plus 2. And from the last, I can factor negative 1, so I'm left with x plus 2. So this factors to be x plus 2 times 3x minus 1. Now I'm left to solve. So set each one equal to 0. We have x plus 2 equals 0 and 3x minus 1 equals 0. We have x is equal to negative 2. We're left with x is equal to 1/3. So we can say that our y-intercept is negative 2, and my x-intercepts are negative 2 and 1/3. One more example. Solve x squared plus x plus 2. So here my leading coefficient is 1, and let's see if I can factor this. So what numbers multiply give me 2, but add to give me 1. No such numbers work, so I have to use the quadratic formula. When working with the quadratic formula, I like to take the time to label my values to avoid doing a silly mistake. So for this one, my a, which is your coefficient of your x squared, is 1. Your b, your coefficient of your x, in this case it's 1, and your c is 2. Now our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, let's work this out. So I have negative, my b is 1, plus or minus the square root of, and when you're plugging in these values, use parentheses to avoid creating a silly mistake. Next we have b squared, so I have 1 squared minus 4 times a, my a is 1, times c, my c is 2, all divided by 2 times a, which is 1. Okay, that's half of the work. Now I just need to simplify. So to begin, I'm left with negative 1 plus or minus the square root of 1 squared is just 1 minus 4 times 1 times 2, we get 8 divided by 2. I'm left with 1 plus or minus the square root of 1 minus 8 is negative 7, all of it divided by 2. Now I have a negative within my radical. We know how to work with that now. So I have 1 plus or minus I, and I can't take the square root of 7, so I just leave it as square root of 7 divided by 2. I can't simplify any further, so that is our answer. So we can say that our x is equal to 1 plus I square root of 7 divided by 2, and 1 minus I square root of 7 over 2. This is also our intercepts. But since in our Cartesian plane, we don't have any i's, we just have x values and y values that represent real numbers, this would be a point that does not cross my x-axis. So just to give you a little visual, this would be a graph that looks something like this, where we do not cross our x-axis. That is why we have those i's. All right, so that's it for this section. Your homework is number 6 through 29, every other odd. This was 3.2 quadratic functions. Thank you.